In this tutorial, we are looking at calculus problems, and it is a tutor-led tutorial. So I'll be sort of working through the problems with you. The questions for this week are from chapter 4 and chapter 5 in the calculus book. Now, I've already done many of those questions earlier in the week, so I thought today we could do some questions involving L'Hopital's rule, because I haven't done those yet in the previous tutorials. So let me know how you're going in the chat. Also, let me know, how was lab test 1? Was lab test 1 okay? I'm assuming just about everybody has completed it. Was it easy? Was it what you expected? Were there any technical problems? You know, let us know in the chat. All right, so keep that chat going. I'm going to share my PDF with you, and we can have a look at L'Hopital's rule. Now, some people call it L'Hospital's rule, but you know, it's a French word. Okay. So this is the idea, and it says that if you have the limit of a quotient and you want to take the limit, but the limit gives you these weird forms, they're called indeterminate forms, then all you do is you differentiate the top, differentiate the bottom, and retake the limit. Okay, so I'm thinking that we'll talk about some of these problems, and you know, you can let me know how things are going in the chat. So look, I'm seeing a lot of chat. People are saying it was fine, silly mistakes, went good, second chance. Rosie, well, 16 out of 20 is still pretty good. So don't worry about it. Alvin, oh, well, maybe 100% next time. So let me go through to the questions. Just go down here. So I've done a lot of these already in the previous tutorials this week. So I'm just going to start at number 20 in chapter 5, and we can work through it. Okay. So let me share my document camera with you. All right, here we go. All right, so this is question 20 from chapter 5. And the idea is to apply L'Hopital's rule. All right, so part A wants you to take this limit. Okay, and what's normal here is you go, okay, well, let's just substitute in x equals 0, and you'll get something like this. You get 0 on the bottom, and so 1 minus 1 equals 0 on 0. So this is a weird form, okay? Some people will look at this and go, what does this even mean? 0 divided by 0. Well, you've got the same on the top and the same on the bottom. So clearly it is 1. It is equal to 1. Well, no, not necessarily. Okay, so this has a special name called an indeterminate form. Okay, so what it means, what that word means, is that we don't know what this is unless we do some more analysis. Okay, So we can't determine what this is without doing some analysis on this. So let's apply L'Hopital's rule. We already see that the limit of the top is 0 and the limit of the bottom is 0. So and these things are differentiable. So that's fine. So let's have a look at how we might apply L'Hopital's rule. So with L'Hopital's rule, you differentiate the top, and that replaces the top function. You differentiate the bottom, so you're going to have 3x plus x squared. So that's going to be something like 3 plus 2x when you differentiate it. And now, if we take our limit again, who can tell me what is this limit going to be? Who can tell me in the chat? If I retake this limit, what is it going to be? Who can tell me on a Thursday in week 5? Cynthia, Nisa, Liz, Nabil, Ningxia, thank you. Okay, so this is going to be 0 over 3 plus 0 e to the 0, which is just 1/3. Okay. Now, I should mention something about L'Hopital's rule here. Okay. So we've checked the condition, the indeterminate form condition, that's fine. We've named the theorem, L'Hopital, and then we've retaken the limit. Okay, and L'Hopital says this limit is equal to this limit. Okay. So it's pretty easy to do. And if you got another form like this here, you could keep differentiating and see what happens. Okay. So what about, say, part B? Let me share that with you. Okay, so here we've got this limit, and we're told that n's non-zero. So and x is approaching 1. So let's have a look at that. And we kind of know that we're going to be using L'Hopital's rule because it says, but let's do the analysis anyway. Okay. So let me go back to my document camera. So it is something like this. And here n is not equal to 0. The reason that n's not equal to 0 is because you'll actually get this will be undefined. So I think that's why they have it there. Okay, so let's try to put x equals 1 in here, and you'll get 1 to the m minus 1 over 1 to the n minus 1. That's 0 over 0. Again, this is an indeterminate form. It could be 1, it could be infinity, it could be 0, it could be something else. We don't know. We have to investigate a little deeper. Okay, now these are polynomials, so they're all differentiable. So let's apply L'Hopital's rule. And we differentiate the top. We differentiate the bottom. And now we see, can we take the limit? Well, let's put in x equals 1 in there and there. Suddenly, it looks like it's going to work out for us. Oh, that should be a 1. Hang on. Sorry, let me redo that. Okay. And we've used, again, l'hôpital. Okay. So I'm checking my indeterminate forms. I'm mentioning L'Hopital's rule, and I'm working out the answer. Okay, so the first one was the third. The second one's this thing here. Okay. Let's do another one. Yeah, this one's a good one. Let's do D. I'll show you how to do D because I think with that one you do a couple of derivatives. Yeah. So let me show you how. Like, let's level up. Let's get to the next level. So let's go back to my PDF and let's have a look at D. Part D. Okay. So let's check that we actually have an indeterminate form, and then we can see if we can apply L'Hopital's rule. Okay, so in my document camera, I would write something like this. So we've got the limit of this thing. So this is ln, natural logarithm. Okay. And so let's do one of the normal things with limits and put in x equals 0. So I get log 1 minus 0 all over 0. So again, that is an indeterminate form. Okay, if I put in x equals 0 there, I get natural log of 1, which is 0, minus 0 all over 0 squared. Okay, so let's do this. So let's apply L'Hopital's rule. So we differentiate the top part and we differentiate the bottom part. So if I differentiate the top, it's going to be something like this. And if I differentiate the bottom, it's going to be something like this. Okay, so now this is where it gets interesting, because in the previous two examples, I could just take the limit. But what happens if I take the limit again? Well, I'll get 0 there and 0 on the bottom, 1 minus 1 on the top, and 0 on the bottom. So I get another indeterminate form. Oh my goodness. Come on, it's week 5. I'm tired. I don't want to do this all again, but I have to. So let's try it again. Differentiate the top. We're going to get this. Differentiate the bottom. We'll get that. And now, can we take the limit? All right, so that's going to be 0. So I'll get negative 1 on 2. So who can tell me what is the final answer going to be? Yes, Nabil. I'm loving it. Don't want to scare anyone. Okay, so this was an exercise. I'll put a nice smiley face there, just to make everybody nice and calm and relaxed. So in this question, we needed to apply L'Hopital's rule twice. Okay, times 2. Yeah, Nabil, it's a good question. Nabil has asked, so we can just keep on differentiating. Yeah, that's correct. That's correct. Now, what you need to be careful of, though, let's say if I differentiated this one more time, then it wouldn't be appropriate to do that. Yeah. So what some people do is they just keep differentiating and they don't know when to stop. Well, Brendan, it's up to you. Well, first of all, you won't be writing anything. You'll be typing it. Yeah, I mean, in your writing assignment, you obviously want to be careful with using full words or expressions. Yeah, I guess you want to make sure that you're cautious. Does that make sense, Brendan? Yeah. But just be cautious. I prefer to write more than less, but I've just squeezed some things in here. So, yeah, Brendan. Sometimes people write this also. They write this. The hospital. Have you heard of that? La Hospital? Anyway, it's up to you. Yeah, look, yeah, you can. I've written it there by La Hospital, La Hospital, La Hopital, La Hopital, La Hopital. I think it's just it's important just to be clear that you're invoking or you're using La Hopital's rule. Okay. Yeah, but it's good. Yeah, we don't want to send anyone to La Hospital. That's for sure, Brendan. Yeah. Okay. So that was two differentiations. Why don't we have a look at the limits where they go to infinity? Because that's kind of interesting too. Okay, so question 21, you've got limits that go to infinity or negative infinity, and you can still apply L'Hopital's rule. You can still apply L'Hopital's rule to many of these questions. So let's have a look. Let's have a look. Now, it's always interesting with these kinds of problems because look at the first problem, right? It's like there's a battle. There's a battle going on between this function, the top function, and the bottom function. Okay, so there's a massive battle going on. Who wins? Does the top win or the bottom win in this case? Who can tell me? Anyone in the chat? Which ones of these functions will win? X cubed plus 1 or x to the 4th plus 1? Yeah, the bottom one wins. Okay, it's too tough. And so, who can tell me what will the limit be as x goes to infinity of this function? Yeah, Hart and Brendan, you're on the right track there. And does plus 1 play any real role as x gets large? Do these plus 1s matter? No, we don't really care about them. Exactly. So really, this is just like 1 on x, pretty much. And we know what happens to that. Yeah? So, let's have a look at it and we can work through it. So I guess what I'm trying to say here is that it's good to think about the problem before you even attempt it. So let me share my screen with you again. Okay, so part A is the limit as x approaches infinity of this. Okay, so if you sort of just did the regular limit thing and replace sort of x with infinity or something like that, you'll end up with infinity on the top and infinity on the bottom, right? So this is another indeterminate form. Okay, indeterminate form. So these are polynomials. We know that they satisfy the conditions of L'Hopital's rule. So what we can do is differentiate the top, differentiate the bottom, and you're going to get some cancellation there. Okay, you're going to get 3 on 4x, and that is going to become 0. So it kind of confirmed what we already knew. Yeah, and this is an easy problem, but it just gets us checking the conditions of L'Hopital's rule. So let's say by L'Hopital. Any French speakers in the audience today? Any French speakers? L'Hopital. Post your best French in the chat. Part B. Let's have a look at the next question. All right, part B. Now, who can tell me who's going to win the battle between these two functions? Is it the exponential or the x cubed? As x get large and positive, Ha says E. Liz says E. Cynthia, E. Isabella, top. Which one? Well, I think you're absolutely right. This function is going to kill this other function. It's going to dominate it for sure. So what would you expect this limit to be without even doing any calculations? What would you expect the value of this limit to be? Yeah, Cynthia. Yep, it's going to go off to infinity. So you're absolutely right. Okay. So if we wanted to apply L'Hopital's rule to that one, what we would do, we would differentiate the top, differentiate the bottom, and just keep applying the rules. Okay. So how do we do that? Well, let me show you. Okay, so we've got part B. So the limit, we already know where we're going. E to the 5x all over x cubed. Okay, so if you put in the x approaches infinity, you're going to get this indeterminate form again. Okay, and so let's apply L'Hopital and see what. I mean, you can see what's going to happen. We're going to annihilate this x cubed until we get a constant. That's pretty much what we're going to do, right? Okay, so we test that again. Well, that's going to be infinity. That's going to go to infinity. So we just keep on differentiating. So we're going to get 25 e to the 5x all over 6x. Okay, because we've got another infinity over infinity here. And then we're going to get 125 e to the 5x over 6. So if we've annihilated that down to a constant. So the limit sorry. There you go. Okay. So you know, that's the long way of doing it, really. You could say here that L'Hopital's rule actually slows you down with these kind of problems. Okay. Let's do a slightly more interesting one. I'm going to do D from this section because I think it's a little bit more interesting. But let me know your comments, your questions, and your best French phrases in the chat. Okay, so this is an interesting question right here. Part D. So what is x times sine 1 on x as x gets large and positive? Okay, this is a very interesting question. Okay, so before we do that, did somebody say GeoGebra? Let me share GeoGebra with you. I'm just going to code it up. So let me share GeoGebra. Here it is. So this purple function is x times sine 1 on x. And you can kind of see what's happening as x gets large and positive. What do you think the limit's going to be, just from the picture? Who can tell me in the chat in French or English? What do you think the value of the function is going to be as x gets large and positive? 1 or un. Thank you, Alvin. Uno. Very good. So absolutely correct. It's approaching 1. So GeoGebra, as usual, shows us the way. Let's do it using L'Hopital's rule. But this particular question is a bit weird because you're like, well, how do I do L'Hopital's rule, bro? Because it's actually not a quotient. So let me show you. And you look at this and go, Chris, you lied to me. How is this even a quotient? It's not, it's a product. I'm angry. Okay, I've had enough. I've just had a lab test 1 and now I have to do a writing assignment. Well, it's not so bad. We can make this into a quotient just by a little trick of algebra. So I'm bringing that x and I'm putting it down there. Oh my goodness, now it's a quotient. How cool is that? So we can work with the function to give us the quotient that we're looking for. Okay, so what is the limit of the top? 0. What is the limit of the bottom? Also 0. So we get that indeterminate form that we're looking for. Okay, if you think about what happens to this function, well, 1 on x gets small, goes towards 0, and sine of 0 is 0. Okay? And that's pretty, the bottom part's much easier. So let's apply L'Hopital's rule, and we can see what happens here. Okay. So now that the difficulty is to differentiate the top and the bottom. Well, sine goes to cosine. And I want to take the derivative of 1 on x, which is negative 1 on x squared. If I differentiate that, I'll get that. Okay, so now you can see, even though it's a mess, that's going to cancel with that, which is great. So now the question is, what is this limit? Well, we already saw it from the picture, but you can go, well, okay, as x gets large and positive, 1 on x goes towards 0. And what's cos of 0? It's 1. Okay? So hopefully you're getting into the idea now. You've got these quotients, you check for the indeterminate form and the conditions of L'Hopital's rule, you differentiate and you take the limit at some point. And you can see in this one, we had to actually rearrange it so that it really was a quotient. Okay? All right. Let me go back to our questions. Oh, this is a good one, 21F. So here's the PDF. And this is a super interesting question right here. Okay, so there is a battle between the top and the bottom. And before we do any calculations, can anyone tell me what you would expect the answer to be without writing anything down, really? And I'll give you a clue. Ignore the plus ones because they don't actually affect things as x gets large and positive. So cover up those ones. And can anyone tell me what's going to happen here? Cynthia, infinity. Ha, 3 on 2. Liz, 3 on 2. Sartak, 3 on 2. Okay. How can you justify that without using L'Hopital's rule? I'd love to hear your, Liz, you are reading my mind. The log laws, okay? Yeah, all right. So let me, Nabil loves it too. Let me share this and I'll do it one way and then I'll show you how to use L'Hopital's rule. So let me share my document camera. So this is 21 part F. Okay. So as people have already said in the chat, the limit as x goes to infinity of natural log of this okay, well, the way I would think about it without L'Hopital's is cover up that and you've got the, like you say, the 3 can come to the front, the 2 can come to the front and the logs disappear. So you get 3 on 2. Okay, that's for me, that's the quickest and easiest way to do it. Okay, so you go, well, the plus ones, who cares, because x is very large and positive. Use your log laws to bring the 3 to the front, the 2 to the front, and then the logs cancel out. You get 3 on 2. How good is that? But let's say they really want you to use L'Hopital's rule. They go, no, 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 you must use it. Well, we can do it. It's not super pretty, but let's work through it anyway. So if we differentiate the top, I'll get something like this. If we differentiate the bottom, I'll get something like this. And I guess what I'm trying to do now is to simplify this. Okay. So I'm going to flip and multiply. So one way of writing it is like this, and I'm going to invert that. And you can kind of see what's going to happen now, right? You're going to get an x to the power 4 down here, an x to the power 4, and you have a 3 on 2. That's where your 3 on 2 is going to come from. Okay, so I'll bring that out the front. You've got you've also got a common but okay. So you can cancel those out. So you're going to get something like this. Yeah. Oops, that's a cubed. Okay, plus x, sorry. Okay, so now it's just about taking this limit. Now, of course, you could use the L'Hopital's rule here as well, but why? I mean, you can just divide the bottom by x cubed and the top by x cubed, and actually it's a bit quicker. So let me divide the top by x cubed and the bottom by x cubed, and this is going to be 0, this is going to be 0, and you're left with that. Okay, but really, if I was doing this problem, I would just try to use the log laws first. They're the easiest and the simplest. What do you think? Yeah, so maybe you're forced to use the L'Hopital's rule with some of these. I don't know. I always hope not, but who knows? Okay, I think I'll do one more, and then I won't see you until week 7. You know, because remember there are no classes in week 6, so it'll be a bit sad. I won't get to see you next week. But we'll meet again in week 7. So let me share my my PDF. Okay, so I'm going to look at 23 now. It's a hard or H question, but you need to find A and B such that this limit is equal to 1. Yeah, I know. It's very sad, Cynthia and Alvin. I'm trying not to shed a tear, but I can't guarantee. Okay, so what values of A and B force this limit to be equal to 1? Okay, so you guessed it, L'Hopital. So let's have a look. All right, I think I'll take a new page for this. Okay. So let's consider, this is 23. So we want to find numbers A and B such that the limit as x approaches 0 of this function x squared equals 1. Okay, so let's see if we can get L'Hopital's rule in here by assuming some relationship or conditions regarding A and B. Okay, so let's try. Let's use L'Hopital rule. Okay, so if I just put in x equals 0, that disappears. Am I approaching? Yeah, if I put in x equals 0, that disappears. This becomes 1. So I'll get 0 on the top and 0 on the bottom. Okay. So let's the 0 over 0 form, which is the indeterminate form, if we put in x equals 0 here and here. So by L'Hopital's, let's differentiate the top. So I'll get a plus b e to the bx all over 2x. Okay. So now if we put in x equals 0, I get a plus b all over 0. Okay, so I get a plus b all over 0. Yeah, Brendan, well, we want to find the value of a. So we want to find it. So what values of a and b force this limit to be equal to 1? Now, you can see that this will be an indeterminate form if a plus b equals 0. So let's assume a plus b equals 0. That means that we can apply L'Hopital's rule again. Okay, so let's do L'Hopital's rule. So we differentiate the top, we get b squared e to the bx all over 2. Okay, and so if we put in x equals 0, I'll get 1 and b squared on 2. So we can stop there. And we want this limit and that limit to be 1. Okay, so now we've kind of got two conditions. We've got a plus b equals 0 and b squared on 2 equals 1. Okay, so let's solve them. So b is going to be, b squared is 2. So b is going to be plus or minus root 2. And then we can get a from here. A equals negative b. So a equals negative or positive root 2. So our two values are root 2 negative root 2 or negative root 2 root 2. That's it. Oh. So I've just kind of switched these signs around just to sort of be consistent with what we've got here. Okay, so if A is root 2 and B is negative root 2, then this limit will be 1. If A is negative root 2 and B is root 2, this limit will also be 1. Okay, so we are super happy. We love it. Okay, let's finally look at another final question. We have a couple of more minutes. Where does L'Hopital's rule fail? Where does it fail? So question 24 is all about the limitations of L'Hopital's rule. Okay, so let's have a quick discussion of that. Explain why L'Hopital's rule cannot be used to find this limit. Okay, have a think about it, everyone. Why does L'Hopital's rule fail for this particular question? Why can't we use it? Who can tell me in the chat? Smash that chat button. Let me know why it fails. Ah, top and bottom can't win. Is it a draw, Ningxiao? It's a draw. It's a tie. Interesting. Interesting. Okay. What are other people thinking? Any other ideas? Hit that chat button if you want to let me know what you're thinking. Come on, there's 64 people here. Let me know what you are thinking. Nabil, not sure exactly, but it has to do with how there is an infinite loop. Ooh, very close. Well, with this one, what is the limit of the top? Nabil, I think you're on the right track. What is the limit of the top function as x approaches infinity? It's a bit of a trick question. Yeah, the problem is with the sine x, yeah? Yeah, it just oscillates, right? So I'll put it into the GeoGebra and I'll just show you. Okay. So let me just show you that. Okay. So the problem here is that the conditions of L'Hopital's rule are not going to be satisfied. Okay, GRG is correct. The limit of sine x is not defined. So this question is about showing you the limitations of L'Hopital's rule. You can't use it everywhere. And if the conditions aren't satisfied, then you need to use a different test or a different technique. Okay, everyone, time is up. So thank you once again. I'm really enjoying these classes. I'll make sure I play some Oasis in week 7 for you, GRG. thank you very much. Have a great day, and I look forward to seeing you in week 7, and I'll miss you next week. All right, everyone. See you later.